So welcome to LNP Renewable System Integrators. Today we are going to learn something about the basics of chill water systems from the BMS and the BACS engineers point of view. So in the part 1 video we have seen what is a chiller plant, how they looks like, and why should we know about this and where can we see those, and we get found some of the part of IOs in the chill water system. In the forthcoming sessions, let us try to know in depth about the sequence of operation which is happening inside the chill water system. As a BACS point of view, how we are going to control it. So this is an example. So with the help of the motor control center, we are going to monitor and control so many signals. Example, fire alarm signal, panic buttons, chill water pressure station units, power on, power off status, and all the pumps, test status, off status, auto status, flow status, fault status, local modes, everything we're going to monitor with the help of these MCCs. So if you go get into the automatic control, okay, so where will we get the cooling demand? The cooling demand will be created by the field equipments like air handling units and the fan coil units. Okay, so if you get the cooling requirement, okay, so and most importantly, there should not be any manual override on off or auto software points available on the, okay, or enabled. Okay, and more secondly, for the secondary chill water pumps to work now, there are certain interlocks. Okay, we can use a hardware interlock also for the shutdown purposes. So there should not be any panic button shutdown enabled, and there should not be any low pressures. Okay, and there should not be any isolation valve shut off. Okay, all these things should be in the normal position. So these are the important interlocks which plays important role in performing the auto operation. So after receiving the cooling demand signal from the air handling units and the fan coil units, the chill water pumps are enabled. Okay, based on the differential pressure switch, based on the flow, okay, the pump will start working and pumping the chill water inside the buildings in the supply line. Okay, most importantly, we are using the pressure control differential pressure sensors for the chill water circuit pumps to operate on its index point selected values, and all these things are hardware to the MCC. We are monitoring entire details of this chiller pumps. So this is the sequence which is going to work. See here how the pumps will work. Let me explain clearly. So in the initial startup, only the lead pump, okay, will work. That is the first pump. Okay, so this also we can schedule. We can make this first pump as a lag, and we can make the second pump as a lead. It means yeah, we can change the duty cycles of these pumps. Okay, first thing, during the initial startup, only one pump will run to satisfy the demand, and if the volume demand is more than 90%, then what will happen? The lead plus first lag heat exchanger valves will open. Okay, see here the valves which is being used in the heat exchangers are getting enabled based on the demand. Okay, during the initial startup, only one will open, and if the demand is more than 90% of the duty cycle of the single pump, then lead plus one lag will open. Okay, and if the duty cycle is again more than the 90% of the two pumps, okay, the third valve will open. Why here valve plays important role? Because before enabling the valve to okay, we should not start the pumps. So pumps will start only when the valves are open. After the opening, if we give any command to the control valves, they should open properly. After the fully opening position or the controlled our command, if you're giving a command to open 50%, if the valve open 50%, then only the pump should run. Unless until if the valve is not opening, we should not operate the pumps. Okay, and if the load is getting decreased, that is less than the 45% of the all the three pumps, okay, the second the third valve, okay, which open will try to close. Okay, and again if the demand is getting reduced less than 45% of the two pumps, only the lead valve will open and only one heat exchanger will work. Okay, So as we told earlier, we have a sequence of operation on the when the load is getting increased. As we told earlier, based on the demand, the BMS of the building management system, with the help of this PLCs, will give the command to the control valves to open, so that the first lag pump will get enabled. Okay, and most importantly, after giving the open command to the valve, if it doesn't open more than 180 seconds, immediately it should raise an alarm that the valve is not opening, so the pump will not get enabled. Okay, once the load got decreased, the, the enabled valves as well as the enabled pump will get to shut down one by one. Okay, and most importantly, after if you provide any sort of command, whether it's open command or close command, if the valve fails to close or open, immediately after 180 seconds we need to raise an alarm. Okay, and most importantly, the pumps will operate to maintain the pressure set point. Okay, and most importantly, why we are providing these time delays, because we need to give a time delay which helps to prevent the hunting in the normal or the plant failure. If the plant got failure, in order to avoid the hunting of pumping systems, we can have a timers. After a particular time delay, immediately we can raise alarms. And as we told earlier, we can consider create the critical alarms with the help of the differential pressure. Okay, if we are setting a set point, okay, if the set point is not achieved after a particular time period, okay, for example, let us have a 10 minutes. Okay, immediately we have to create a critical alarm. Okay, so as we told earlier, we had already installed the both on the primary flow side as well as the primary return side of the heat exchangers, that is differential pressure transmitters, and also in the district cooling plant controller side also, if the differential pressure signal exceeds the nominal set point, example, if you are setting a nominal set point of 35 Pascal, okay, if the pressure value exceeds that set point, immediately we have to raise a critical alarm. And see here we have a video how a PDIT or a flow transmitter works. This is an example. See here, now there is no flow. Okay, so we are providing a 24 volt DC signal with the help here. The input is current. We are providing a current and we're taking out the current. Okay, see here, we're providing 20 amps current. Here there is no flow, so we are getting a minimum current, that is 4 milliamps. Okay, see here, the flow is 50%. Now we are providing a 20 milliamps power and we are getting 12 milliamps. So it means 50% of the flow. Now here the flow is 100%. So how, see here how a physical quantity is getting converted to a electrical parameter. Here we are providing 24 volt DC, 20 milliamps. Here that is 100% flow, so we are getting a 20 milliamps output. So this is how flow transmitters works. So we had installed temperatures on the primary flow side as well as primary return side as well, in order to monitor the temperature of the water. And as we told earlier, there should be a flow temperature set point. If the flow temperature set point is greater than 5.5 degrees Celsius, more or less, immediately we have to raise the critical alarms. Okay, and also in the return line, if the temperature is less than 14.5 degrees Celsius, immediately we have to raise a critical alarm. So now see here how the chill water startup routine is working. Okay, the modulating valves on the primary side of each heat exchanger will be fully opened by the PLC. Okay, and also the isolating valves on the secondary side of the heat exchangers also will be opened by the PLC. Okay, so once we got the demand signal from the AHUs, VAVs and the FCUs, immediately the automatic mode will get enabled. Okay, and most importantly, without opening the valves, we should not run the pumps. So that is an important interlock we need to maintain. Okay, and also pumps will run based on the pressure set point values. See here, there is a example video how the control valve is working. We are operating it with a current as a source. See here. So So we are providing the 20 milliamps of foot, it is opening full, the water is going inside, and when it is 0 it is fully closed, the water is not flowing on the other side. Okay, the valve is closing. So when it is a 4 milliamps, minimum it is 4, when it is 8 it is 50%, when it is 12 it is 50%, when it is 20 milliamps it will open fully and the water will go to the other end. So once the automatic mode is enabled, everything that is pumps on the secondary side, isolating valves on the secondary side, modulating valves on the primary side, everything should be in the auto control. Okay, we have to ensure it. And when the plant shutdown will happen, if there is no demand from the air handling units and the fan coil units, okay, which is serving the field side, automatically the entire system will get shut down one by one in sequence. So this is an example how a AHU works. So as we saw already earlier, today we are discussing about the chiller. So this is how the chiller, there is a supply line, this is a return line. So it is supplying it to the air handling unit. This is a small chiller, one of the example. And see here also the chiller is there. Okay, here also the chiller is there. See how it is working. So it has a supply line and as well as a return line. It is supplying the entire building. Okay. Thank you so much. To learn more, okay, and to do the projects with us, feel free to contact us. We have provided contact details here. And to know more things like this, please subscribe and press the bell icon. And if you want to do design, installation, testing, and commissioning projects for the solar power plants, feel free to contact us. We are ready to serve you. Thank you.